Hello, my name is Victoria Brown, and this is Lab 3 Circuits. The purpose of this experiment is to use the principles of energy and current conservation to predict the behavior of circuits containing resistors in series and parallel, use multimeters to measure the actual values of conventional current and potential differences in the circuits, as well as examine the behavior of ohmic resistors and capacitors. The main findings of this experiment were the predicted and actual current and voltage were equal, and current is time-dependent in exponential form. Some fundamental principles that we will use throughout this experiment are Ohm's law, which is delta V equals IR, the loop rule, which means that delta V equals 0 across the loop, and the node rule, which means IN equals I out, looking at current. On the right, we have a variety of equations that will be used throughout this experiment to help us measure values. For this model, we will use an online circuit construction kit to explore time-dependent voltage and current in an RC circuit. Per the lab instructions, the system is going to be the circuit and surroundings are going to be everything else. For the purposes of this experiment, it is assumed that wire resistance and emitter resistance is negligible. In part 1, we had a circuit with two 1.5 volt batteries, a 47 ohm resistor, a 100 ohm resistor, and two emitters. We assume that I1 equals I2 because they're in a series, and by prediction using our equations, we have that I1 and I2 equals 0.02 amps. The actual value for I1 and I2 were 0.02 amps as well, and this was the same when inserted backwards, and the current stayed the same. We then had a circuit with two batteries, the two resistors, one emitter, and one voltmeter. Delta V equals 3V, and I was 0A, which is 3 volts and 0 amps. And this is due to the model now being an open circuit. The potential difference that was seen for this circuit, some important values were the current, which is 0.2 amps, and then we have our AB value of 3 volts, CD of negative 0.96 volts, EF of negative 2.04 volts, with all other values being 0 volts. So our overall delta V was 0 volts, as we had our positive 3 from the batteries, and we then subtract EF as well as CD to equal a final of 0 volts. The emitter does not change in the presence of the voltmeter because the current is not able to flow through, which means that the circuit is unaltered. And if we look on the bottom right, we can see a visual representation of the potential difference throughout the circuit. Some circuit resistance values that we found were 48 ohms, 102 ohms, and 0 ohms for both the wire and the emitter. The current ultimately increases to 0.06 amps, the current splitting at the node, and with there being a resistance of 0 ohms, the overall resistance decreases. In part 2, we had an RC circuit with a 10 ohm bulb, a 20 ohm bulb, a 9 volt battery, and a 200 mF capacitor. The 10 ohm bulb is represented by the top, and we have a charge time of 8.2 and a discharge time of 10.6. The 20 ohm bulb is on the bottom, and we have a charge time of 14.1 and a discharge time of 17.4. Here's a graphical representation in which our equation was negative 0.1667 minus 0.00563. So our experimental RC was 5.98 and our theoretical RC was 6. With this experiment, there was room for errors such as inaccurate voltage and time recording. You can pause and read the question, and for this one, there have been some resistance, unlike the model, and there also been a decrease in the current. You can also pause here to read the question. And for my explanation, in this experiment, the resistance is negligible and the model would be consistent with an instantaneous full charge. This would not be the case in real life, as there is actual resistance present, and so the capacitor would charge at a slower rate. In conclusion, the lack of resistance is ideal for more accurate circuit values. Voltage and the currents at various locations in the circuit, along with resistors and capacitors, are dependent on time and have been observed to exponentially decrease over time. Thank you.